Okay, okay. So, this is my second video in consonance with the first video that we have, the DHCP. Those are concepts, and this time we're going to explain it through the use of packet tracer. Okay, so as we all know, on the slides that I gave you in the DHCP, basically there's a part there that the the way we are going to configure it one by one. Okay, so all we have to do is to understand this one and apply it in our packet tracer, right? Okay, so basically this is how we do it in packet tracer. But firstly, this will be the topology that we are going to use. Okay, so in this instance we have a router here. Okay, two routers, and we are going to elect this router to become the DHCP server. So this router will give out IP addresses in this network and in this network also. So prior to this one, I have already computed some of the addresses that we are going to use. But if you want to see how did we come up with the addresses, it looks like this. So we will be using CIDR and BLSM notation for maybe in the next activity. BLSM CIDR is a precursor of the BLSM notation, so therefore we must understand how CIDR works. So CIDR is an classless interdomain routing, which is totally different from what we call subnetting. Okay, the subnetting, although prior to studying or mastering the CIDR, you should master also the subnetting first. Okay, so that you have a full idea on how to segment one network address into a many network address. So what makes it different, what makes CIDR different from subnetting? Number one, because CIDR has prefixes. Okay, when we say prefixes, these are the number of bits consumed already in a particular address. Like for example, if we are referring to class A, so we have already consumed 8 bits from there. That's why it is N. It is labeled as N. So if it is class B, that will be 16. Therefore, it's n.n.h.h, and class C for n.n.n.h. So for each octet, you have already consumed those bits until the 24th. Okay, so that makes it a prefix to that particular address. So each prefix is also a subnet mask of that particular address. Like for example, if you are referring to /8, that is 255.0.0.0, 16 is 255.255.0.0, and /24 would be 255.255.255.0. Okay, in that manner we can control the number of bits that have been consumed in that particular network rather than using one address and wasting a lot of IP address like class A. So if you will be working on class A, only one address has 16,777,216 IP addresses, which is a lot of waste. That's why we have to perform any of the tasks, any of the computation or notation that we need to lessen the waste of our IP addresses. Number two, the CIDR is different from the subnetting, because subnetting uses classful addressing. This one is classless, means it does not point to any of the classful addressing. Okay, so that means if it is not that, if it does not point to any classful addressing, it may not be a class A, class B, or class C, right? So as we know, the 10.15.100.0 may be a class A because this address, the first octet, belongs to the range of 1 to 126, right? So 10 is inside the range of 126, therefore it is considered as class A. But if you are going to notice that the subnet mask of this address is /24, that means 255.255.255.0, which is a subnet mask of a class C. So this contradicts the fact that a class A has a subnet mask of 255.255.255.0.0.0 rather than this one. So that makes this one as classless. Okay, so to further we're going to compute an example of how classless interdomain routing is computed here. Let's say, for example, we have 198.15.224.0/21, and we are going to create at least 50 subnets. So I have already taught you the 6 steps on how to subnet. Since CIDR is also a subnetting procedure, we have to follow the 6 steps also. But number one, since this is not a classful addressing, but still we need to plot out the binary value of these addresses so that we can identify where to stop and where to begin counting the number of bits to be borrowed. Okay, so 198.15.224.0, then we will look for the /21. That means that there are 21 bits have already consumed in this particular address, and what's left would be our own subnets. Okay, so since 198 is still /8, so it is under /21, and 15 is still under /21 because the first octet and the second octet adds up to 16 only. So we have to find the 21st. So if this is 16, 17, 18, 19, 20, and 21. So 16 plus 5 is 21. So from these bits here of your address cannot be used anymore. Okay, so I marked it here so that the first 21st bit cannot be used, and the last bit from the third octet down to fourth octet still can be used. Now we are going to erase this one first. So in order for us to create 50 subnets as our requirement here, we have to borrow the bits. Okay, you have to borrow the bits. So take note, this portion here can never be used. This portion is still 3 bits. So how many bits are we going to borrow if we are going to create 50 subnets? So the formula is 2 raised to the power of 2 minus 2. Okay, it should be equal or greater than our requirement, right? So if we are going to borrow 6, that isn't enough. That's 2 raised to the power of 6 is 64 minus 2, that's 62. 62 is it's enough for 50. And if you're going to use 2 raised to the power of 5, let's say for example 2 raised to the power of 5 can only give you 32. 32 is not sufficient enough to cater 50 subnets. Okay, and if you are going to borrow also 2 raised to the power of 7, that's way too many. It's almost half of what we require, so we don't need to do that. We are wasting too much, so the purpose of which is to lessen the waste, right? So 2 raised to the power of 6 bits is enough. So starting from here down to the 6th bit, we are going to count 1, 2, 3, 4, 5, 6. So from this point, this is where we put a demarcation line to determine that these are our subnets and these are our host. And the 6 bits here is the number of bits that we borrowed. Okay, so since we have already the borrowed bits, and we can identify already what would be our bits consumed in that particular address, we have to count them all. In this instance, so since we have already 21, right, then we consume 6 bits, so therefore we have /27 network. So if we have /27, we are going to convert that into a correct subnet mask, which is 255, 255, 255, and 224. 224 because we have these 3 bits here at the 4th octet. That would be 128 plus 64 plus 32. That's 224. So in order for us to get the range, we have to deduct 256 to 224, and we have the range of byte 32. So each of the network has a 32 bit 32 range. Okay, 32 IP addresses inside it. Okay, so to plot a particular network, so we have subnets number 0, 1, 2, 3, 4, 5, so on and so forth until 64th IP address or network address. So basically that is until 63. So 0 to 63 is 64. So in this instance, we are going to plot out our subnets. That's our subnets 0, then 32, 64. So you will notice that we have incremented by 32. Okay, until such time we reach the very last portion, which is 231.224. How? Then you compute this. So this is already 7 plus the 224 here. So therefore you have 231. Then the 3 bits here, which is the 224. So 231, 224. This will be the IP address that we're going to use later, and the broadcast address. Okay, so much more. If you have any question with the subnet, with the CIDR, you can point it out in our GC. Okay, so the first thing that we are going to do is we are going to configure our router here. Okay, so that we can put specific IP addresses, to make this one work. So let's make this font a little bit bigger so that everybody can see what am I doing. Okay, so let's try it. Okay, there, a little bit bigger. No, so enable config T. So we have to skip the initial configuration first, and we go directly to the interface configuration. So we have to configure G00 and S00. In G0/0, then we are going to put the IP address for the gateway here, and that is, we assigned already the network 224.0. so therefore this is IP add, so 198.15.224.1. so that would be the gateway address. Then give the subnet mask 224, enter, no shot. Okay, same is true with the int se 0/0/0 and IP add. So take note, this is the 32 network. So we are going to put this one as 33. First IP address 255.255.255.224. Enter, no shot. Okay, so we jump to the next router. Then we are going to configure also this router's interfaces. Okay, CLI, no, then enable config T, then int G0/0 IP add. So take note, this area here is network 64. Okay, so paste. Therefore it is 65 is the first address of network 64, then 255, then 255.255.224. Enter, no shot. Also the int se0/0/1. Okay, IP add. Take note that the other side is 33, therefore this is the 34 side. So 255.255.255.224. Enter, no shot. So that's basically make our network work now. We can ping our own gateway. Let's try it. Okay, ping our gateway. No. Ping our gateway. No. Why? What's the reason? Number one, we don't have any IP address. So that's why in this router here we are going to elect that this router will become the DHCP. Okay, that will give an IP address to this network and to this network. So in order for us to configure that, we have to identify what addresses to be involved. So take note that the addresses will be the 0 network and the 64 network. So there will be two DHCP pool. Okay, so first you have to give the command IP DHCP, then exclude address, meaning these are the IP addresses that we don't want to give to the PCs. Okay, until 9. So when you are going to identify a range of IP addresses that you don't want to give to the client, therefore use this type of addressing. So you have to separate IP addresses that would create a range. Then if you are going to exclude only one, so all you have to do is identify only one also. So take note that the end address here is 32, so 30, we are not going to give the 30 IP address. Okay, then the next thing that we're going to do is IP DHCP pool, IP DHCP pool, then LAN 1. So LAN 1 will be the name of our pool address. Okay, LAN 1 will be the name of our pool address, which is intended for the network here. Okay, so this is a variable. Any name will do as long as it can point to that particular network computer. Then we have to put the network of that particular LAN, which is the 0 network with the 255.255.255.224. When the default router is the gateway which we use to configure in the G00. Okay, and that is the IP address 224.1. We can also use the DNS server, no? Although we don't have any DNS server, but we can assign one already, and that too, later we are going to create a server here, a web server that points to a points a computer with a web service IP address of .2. Okay, and we can also use the domain name as www.gsm.com. That will be the example. Okay, so that way that's good to go. Okay, so you go to your PC. Okay, go to desktop here, then you have to ask IP address from the server. There you have already your group of IP address. Okay. Here, desktop, there, so it's successful already. So basically this computer now can ping its gateway. Yes, successful. Okay, this computer can ping its gateway. Yes, successful. Can this computer ping this gateway? Fail. Why? So later we are going to find it out why. Can this, since this group of computers here would like to get the data, also the DHCP from this DHCP server, so we have to create also a pool of DHCP server here. So again, first we are going to exclude addresses. That is 64, meaning I'm not going to give 65 until 64. Okay, I'm not also going to, again, the next network is 92. Is the next network 92? 96. So meaning we are not going to give the 94. Okay, so we're not going to give 94 there. So the next command is IP DHCP pool LAN 2, right? Then we have to identify the network that we are going to use for LAN 2. That would be the 64 network. Okay, the default router will be the gateway of the next network here, the 64 network, which is the 65. Okay, we also have to put also the domain name for the DNS server, points to that address, and the domain name of gsm.com. So those are the commands. So if we are going to show this router here, we can identify what are those commands we presented. Do show run. So if you look at that one, you have already the information pertaining to LAN pool, LAN 1 pool, and LAN 2 pool. Okay, and the addresses excluded which are not able to, which this router cannot give to the host or the client. Okay, so can we now ask for IP address here? Stop, static, then you go to HCP. Voila. So So why is it that this PC cannot get an IP address from this router? And by the way, when the client would ask an IP address from the DHCP server and the DHCP cannot be seen or cannot be found, there is an automatic private IP addressing given to this particular PC. That's why the 169.254 is an APIPA, which stands for automatic private IP addressing. Okay, so this indicates that there is no DHCP found in this network. And why? So these are the two questions that we need to answer. So basically there are two reasons why this group of computers here or network cannot find the DHCP server. Number one, there's no protocol in between. We did not put protocols between the two routers. Diba? It's imperative that these two routers should have protocol. Number two, LAN2 has no idea where to get the DHCP because the DHCP is not part of its own network. It's not its router. It's from the other router, right? So we have to set this one up and set this one up so that these two computers can have your DHCP address. So to do that, let's set protocols in between. Okay, everybody knows how to set up protocol. We are going to use EIGRP lang para to make it very simple, no? So router EIGRP N, then no auto summary, then network. We use the network 0 with 0.0.0.31 wildcard mask. Okay, and the 32, right? Wildcard mask. Okay, this end of the router also, we are going to configure also the router EIGRP of the same autonomous system number. Okay, then no auto summary. Then we create a network of 64, okay, with 0.0.0.31, and the other one is the 32. Okay, so if you look at that one, no, it's a matter of seconds. Automatically the two routers see each other. Why? Because of the link state type of protocol, no? So it is an indicator whether you have already exchanged information. That's how fast link state protocol is compared to distance vector. Okay, now we have answered already the protocol, okay, the reason number one, and we go to the reason number two. Reason number two is we let this interface here identify where should it get its IP address. So therefore it can point to this router here by pointing the address here. Okay, by using the IP helper address, it looks like this. So in G0/0, then you give the command IP helper address, then that IP helper address will point to the IP address in this router, because this is where your DHCP belongs, right? So you got 33 there. Okay, so do show run. So that's the only command that you are going to use, no? So you have your gateway and the IP helper that points to that gateway from the other router where to get the DHCP server. Okay, so let's try to access that server. Delete this one first. Okay, oops, there. Baka bantay mo, automatic siya dayon, no? Okay, then the other one, dali lang kaayo, di ba? Okay, there, it gets its IP address. So basically this computer here can ping its router. Okay, this computer ping its router, this computer ping the other router, this computer here can ping its counterpart PC. There you are. So basically that is the steps on how to configure your DHCP using your router. Okay, so I hope um, you can also use this command in order for you to determine kung ano, to determine what's the verification of your DHCP. Okay, sometimes um, we are going to give this command here and say do show run pipe, okay, section DHCP. Dili siya kakita, no? So it depends on what type of router are we using. Okay, so it's not a problem because it's only a verification. So like that one, so this one might is sometimes it's a problem, no? Maybe you can go out to the privilege mode just to give that command. Let's try it. Exit, then show run pipe, then section DHCP. So dili siya gyapon kakuha, so maybe it depends on the router, I guess. Okay, so it's not a problem. So the next topic that we are going to have is, what if I have a DHCP server and we are going to give IP address to this area here, to this area here, and to this area here. So meaning I don't have any server that belongs to each router. Okay, and that will be the next topic of our this video. So for further questions, you can put it up in our GC so that I can determine whom to answer, and at the same time I'm going to um, load several lab activities for you to work on. I will make it very difficult so that you can think deeper. Okay, so I guess that will be the end of my video already. Thank you. So again, if you have question, put it up in our GC. Thank you and goodbye, class.